Okay, now let's look at some of the motivations behind this lab that we are going to treat, bioelectronic lab. Now, we have various means of generating electrical energy. So we look at the various sources with respect to how it affects the environment. So we are going to look at this context globally. Then we narrow it down to Ghana. So when we look at the global point of view, uh, we've taken some portion of the sources of generating electrical energy. So about 20.3% comes from coal, 29.1% also comes from natural gas. Then other fossil fuels also constitute 5.4%. So when you look at the whole percentage that is coming from these fossil fuels, it's about 54.8. Now we are having different kinds of renewables coming in. But then our concern is not the renewables. The main problem to tackle over here using power electronics is the non-renewable. So this is how we get non-renewable sources of electrical energy. That is the fossil fuels. So let's look at it from the Ghanaian point of view too. In Ghana here, we try to tackle everything. Like we look at the renewable, both the renewable and the non-renewable methods of generating of electrical energy. So we see the hydro taking almost 40%, which is very good. We have the thermal, which is also taking 59 or taking about 60%, which is also very good. But then the remaining 0.2% is taken care of by the solar technology. So this definitely tells us that solar energy has not been going on well yet in this developing countries like Ghana. So first of all, let's look at how this thermal energy can help us to get energy. Just a brief overview before we dive deep into it, because this is where our problem solution is going to be concentrated on. So first of all, let's look at a block diagram or how the stages uh, come by when we are dealing with generation of energy through thermal means. So if I have a thermal energy or I have a thermal energy source like coal, we can have coal like this. Then if you try to heat the coal, at the end of the day, you are going to get heat energy out of it. So we get our heat energy. So this heat energy coming out, we can just use it to heat a boiler. So if I have a boiler here with water in it, with water inside the boiler, so when I apply heat of this direction, at the end of the day, we are going to get steam, steam from this. We have a lot of mechanisms that take place in this stage, whereby we try to dry the steam, do a lot of mechanisms on it so that we can use the energy coming out of it in the form of mechanical energy. So this mechanical energy or the heat, the heated steam that is coming out is now being used to turn a turbine. So as the steam is coming out like this, if I have a turbine which is mounted in this shape, if I have a turbine this way, definitely this steam is going to turn this turbine in that direction. So with a high pressure of steam coming out, you'll be able to get a very high mechanical energy on this turbine. Now, let's deal with maybe a belt. If I try to connect a belt from this turbine to maybe an electrical generator. So let's just couple it this way. This is an electrical generator. So with this turning of the rotor of this electrical generator, at the end of the day, we are going to get electrical energy coming from this. This is just a simple overview of how the heat energy is converted to electrical energy. So we heat the boiler with this kind of fossil fuel, which can be coal, natural gas, or whatever. Then we use it to heat water in the boiler. The water comes out with a high pressure of steam. So this steam will then be used to turn the turbine. So with the turbine also coupled to a generator or electrical generator, we can have the generator generating electrical energy from its terminals. So this one can be utilized. So as we have seen it like this, we will now look at how the working of this whole setup will affect the efficiency of energy that is being generated here, because we know definitely that we are going to put 100% of energy inside, and we are expecting 100% energy out. But in a setup like this, we will not be able to get 100%. Definitely it will go down. So we are going to look at what happens within this and how the energy drops and how much energy is dropped for us to be able to get the output energy that will be used for other consumptions or purposes. So the next video, we are going to look at what happens between this 100% energy input and the amount of energy that is taken out of this generation system. So the next video will continue.